Today we are working on lesson 4-6, estimating square roots. We do not have any vocab that's new to this section. We will be using the knowledge that we learned in our square root section to help with the estimating of square roots. And essentially, the most important thing that we will be taking advantage of is those perfect squares that we talked about. Those are the square roots of a whole number squared, like say 16 squared, or I'm sorry, the square root of 16 would be 4, which is 4 times 4. The square root of 25 would be 5, the square root of 36 is 6, and so on and so forth. The first example here says estimating square roots of numbers. And the question is, the square root of 30 is between two consecutive integers. Name the integers and explain your answer. So the way that I like you guys to do these is you're going to have square root of 30, that's what the question is about. And then you're thinking of two perfect squares that surround that. So you essentially you want to focus in on that number 30, keep going down until you find a perfect square. So when we go down 29, 28, 27, 26, 25. 25 is a perfect square. So you're going to put that there. And then you also have to go up. So 31, 32, 33, 34, 35, 36 is a perfect square. So that would be there. And when you find that out, you can take the square roots of these, and they will always be one away. If they're more than one away from each other, that means that you missed a perfect square and you should try again. As soon as you find one, if you know it's the smaller one, then you know the larger one is going to be one integer higher, and then you could square it to find that square root. If you find the larger, you could go down one integer and square that, and that would be the other perfect square that you need. So that is how you're going to start setting these up. The other thing that you will be asked to do is actually come up with an estimate for the square root. So it is not going to be a whole number. We know that 5 squared is 25, 6 squared is 36, 30 is somewhere in between that. So we know there's no other integer in there that we could square. So this is going to be an estimate. And it is actually going to be a decimal that goes on and on and on forever. We know that. We also know it's going to start with a whole number 5 because it's somewhere between 5 and 6. So then we put our decimal. And then our job is to decide, well, about what is it going to be? When I say about, in the middle, let's see, we'd have as our options 5, 9, so those would be all of our options from 5 and 1/10 up to 5 and 9/10. What I like you to do once you have all of this done is to write what is the difference between 25 and 30. So those are 5 apart. Between 30 and 36 is 6 apart. These numbers are really close to each other, and oddly, they're the same as this, which is completely coincidental. That's not normally how it happens. But as far as differences between perfect squares go, these ones are really close. And what that means is this is probably going to end up being somewhere towards the middle. So I would say that a good estimate here would be 5 and 5/10. When you're doing these, I really like you to at least get on the right side, the correct side of the 0.5. So if it was somewhere over here, you could say, any of these, if it's somewhere over here. So what that would mean is this was small and this was big, then you could put any of these. As long as you're on the correct side of 0.5, I think that's close enough for our estimation purposes. The next question here is about a lost hiker and a helicopter covers a square area of 150 miles squared. What is the approximate length of each side of the square? So we're going to do a similar thing here and put 150 in the middle because that's what we're trying to estimate. And then we need to come up with our perfect squares. Below that is 144, which is the square root of 12. Because that is smaller, we know that this is going to be 13, which is 169. And then we can figure out about what the square root of 150 is. Again, it's not going to be exact. It's going to be that wavy equal sign because we're just estimating. Our smaller number is 12, so 12 is going to go there. And then we figure out how far apart these are. So that's 6 apart, and this one is 19 apart. You can see that this is going to be closer to 144 than it is 169, and it's actually more than double the closeness. Does that make sense? So if you doubled that, you'd have 12. If you tripled that, you'd have 18, and it's still more than that. So this is going to be way closer to 12 than it is to 13. So I am going to actually say 12 and 1/10. They wanted you to round your answer to the nearest mile. So you can round that and say it's about 12 miles. When we move on to example 3, we have approximating square roots to the nearest hundredth. And there's a formula here that we're going to. So when we look at example 3, we're looking for the square root of 200. So the first two examples, we were going to the nearest tenth, and that was good enough. Here they want us to go to the nearest hundredth. So again, the first thing that we're going to do is find those perfect squares that surround 200. So 225 is up here, and that is the square root of 15. So that means this would be 14, which is 196. So we know that this is going to be 14 point something. Okay, we don't know exactly what yet. To figure this out, the second step is to take your 200 minus 196. So we do 200 minus 196 and get 4. Okay, so that's similar to what we were doing when we did this. The next step here, though, is to take 225. So our larger perfect square minus our smaller perfect square. So this is different because in the previous examples when we were going to the nearest tenth, we were just then figuring out the difference here. Here you're actually figuring out the difference between your two perfect squares. So this would be 29. Okay, so we have the difference between our number that we're trying to estimate and our smaller perfect square, and then the difference between our two perfect squares. The next thing that we're going to do is take those and turn them into a ratio, so 4/29. When we divide that out, 4 divided by 29 is about 138 thousandths. And then finally, you are going to add that 138 thousandths after our 14, and we get 14 and 138 thousandths. They wanted us to round to the nearest hundredth, which is here, so we would think about, is it going to stay a 3 or bump to a 4? We look to the right, 5 or higher, so we're going to bump to a 4, and we get 14 and 14 hundredths. And that is a really good estimate for square root of 200 to the nearest hundredth, which is really a very specific number. And we were able to do that through this formula where we took the square root we were trying to estimate minus the lower perfect square, got that. Took the larger perfect square minus the smaller perfect square, got that. And then we take this over this, so you turn that into a fraction, and then divide 4 divided by 29. Take it out to the thousandths place so that you can round back to the hundredth place. That is that. The last example is about using a calculator, which we're not doing because I don't know if you have a calculator at home. What I want to look at next is page 190. So 190, 191, your textbook adds this as like a kind of like a sidebar, but this is actually super important when you get into algebra. So I want to make sure that we go over this and how it works to simplify a square root. So if we have the square root of 48, what we want to do is find any perfect square that's in this number. So 16 goes into 48, and it goes in three times. We know what the square root of 16 is because that's a perfect square. So you can separate this and think of it like this. And we can take the square root of 16, which is 4. We would write 4 times the square root of 3. You don't need to put the dot in there. This is just like when you have a number outside parentheses, it means that you're going to multiply. So 4 square root 3 means 4 times the square root of 3. Looking at another one, they give us 3 square root 2 minus square root of 8. We can't do anything with this 2, but 8 we can split into 4 times 2. And then we can take the square root of 4 times the square root of 2. And we know that the square root of 4 is 2. So we now have this. Because our square roots match, we can think of that as being similar to a variable. So if we had, say, 3a minus 2a, we could combine this and say, okay, if I had 3a's and I took 2a's away, I would have 1a. Well, here I have 3 root 2 minus 2 root 2, so it's 3 minus 2 is 1, and then we still have the square root of 2. And just like our variable would simplify to a, this simplifies to the square root of 2. Let's try one more like this. Square root of 12 plus the square root of 75. So the square root of 12, we can break that up into the square root of 4 times 3. Square root of 4 is 2. So this would change to 2 square root 3. And then the square root of 75, I can break this into 25 times 3. Square root of 25 is 5. I would still have the square root of 3. And then I can add these together because my square roots matched. If they didn't match, it would be like having, say, 3a plus 2b. We couldn't do this because our terms are not like terms. So watch that your square roots actually match, and then you can add and say this simplifies to 7 square root 3. What I want you guys to do is some problems from each of these. So on page 188, we have 17 to 32 all. And page 191, we have 3 to 15 by 3s. So 188, 17 to 32 all, 199, 3 to 15 by 3s. I will see you guys soon with the review of that homework and the other lesson for the week. See you then.